I think we are live. Hi everyone. Sorry for streaming it little bit late. Reason being I have no electricity in my area. My devices got just disconnected and so on. So special thanks to Pandit for like understanding the things and making this stream again at a different time. So let me just quickly go you through around the build week camp that we are having. So as you know, we are like collaborating with DevCon and each global team to making this particular boot camp possible. So how this particular curriculum would look like? So yesterday we have the session with Dinnatu, like where she has just covered around the things a bit around Ethereum, how you can write your smart contract, like the bit around the remix ID and testnet deployment and so on. So if you haven't watched, you can like go through the Ethereum welcome video and check it out how the things in the background work. So this will eventually gonna help you out understanding this particular like today's agenda. Like today we will be deep dive into like smart contracts and Solidity and some workshop for the same as well. So for that, like Patet is having like pretty good experience in smart contract development and so on. So like he will be covering that side being. And then we will be deep diving into how you can build your first app, Ethereum stacks, and then we will be kicking off our bootcamp. So and things like that. And what makes this particular camp a bit more beautiful is that like we will be having a demo day in a live manner, specifically in Delhi. So if you're from based out of Delhi, you can join us live, apply for the event, and join us out. So now, without further delay, like I would just hand over the things to Pandit. Like he will cover it out bit about himself and then how you can write your first smart contract and bit about the topics that we are gonna discuss today. So hand over to you, Pandit.
Hey, thanks for having me, Bhavna. And yesterday, Unnati covered a lot of things about Ethereum. Today, we are going to talk about Solidity smart contracts, some of the best security practices of smart contracts. And by the end of this workshops, we are going to deploy ERC20 for smart contracts by following industry practices. So, my name is Pandit. I'm currently working as a lead blockchain engineer at Proope. I previously worked as a DevRel engineer at Catapulta and developer advocate at the GraphDAO. So, before diving jump, as I said, we are going to code. Before diving rightly jump into the code, we are going to learn bit about EVM, very basic overview, and then we are going to see like what are the data types and like what are the smart contract life cycles, then security practices, and at the end we are going to deploy smart contract. So let's understand EVM first. Let me share my screen. Oh, the camera is off. Can you can you see my screen? If you Yeah. So before we write smart contracts, we need to understand where they actually executes, and the execution in my environment. Like most of the times, you might have heard about EVM, which stands for Ethereum Virtual Machine. So think of it as a like you also heard about a lot of narratives like Ethereum, the world computer. So it is the decentralized computer that exists on Ethereum node. I hope yesterday Unnati covered all of this, and that every node executes the exact same instruction, ensuring everyone reaches the same results. So can you see my screen? Yeah, sure. So let's start here. When any smart contracts we compile, it becomes EVM bytecode, and the bytecode is deployed on chain, and they are like they become immutable, and this is why we call it and then like virtual ROM. I added it in a diagram. And just like you can think it is as like just like a ROM in computer that store instruction permanently, and the EVM stores the deployed smart contract code. That code doesn't change like every time someone call the contract. And whenever we call smart contract, the contracts create temporary execution that called machine state over here. And there are four important components like uh, stack, gas, and program counter. Also memory, you can think it as memory as in like RAM. And storage directly belongs to smart contracts. Here you can see. And like we are going to declare learn about variables like balances, and you are going to deal with mappings and like all the token data on the blockchain. So all this directly connected to storage itself. And like let me wrap you in the like, if you are seeing this, let me wrap you in the like in single line how this life cycle works. So it is like very simple. Like when you do transaction, it converts into byte code, then it goes to program counter, then gas, stack, memory, storage, and at the end it updates the blockchain state. So that's the very basic overview. Like EVM itself, like EVM architecture itself, a very huge topic, but we covered what we need. So today, like let's start directly into coding. We are going to like as our topic is not Solidity, example solidity.org. So what is Solidity? Solidity, you can see the as the documentation here. Solidity is object-oriented, high-level language for implementing smart contracts, and smart contracts are programs that govern behavior of accounts within Ethereum state or like EVM chain state. Unnati covered this yesterday. Solidity is a curly bracket language designed to target the Ethereum virtual machine, and it is influenced by C++, Python, and JavaScript. Like if you know C++ and Python, then definitely Solidity going to be very a simple language for you. And also Solidity is statically type support inheritance. Like if you know ops concepts, like if you've been coding in different languages like Java, they have like object oriented. So Solidity supports inheritance libraries and complex user defined types as well, just like we do in Rust, and among like other features as well. With Solidity you can create different smart contracts. Like in DeFi you can build NFT and DeFi protocols, and like crowdfunding, auctions, like voting, any smart contracts as well, multi signature contracts. So let's that's the basic overview of Solidity language. You can go through documentation and learn more about Solidity. So let's directly jump into coding and understand one by one. And let's start coding. I think it's take time. So you can go to remix.ethereum.org, and this Remix is online IDE for writing smart contracts on EVM chains. This is for workshop purposes, because in industry we use blazing fast tools like Foundry and Hardhat. We are gonna use Foundry for deploying smart contracts. So here we are. You can see we are on remix.ethereum.org. Let's create a new workspace. Create a blank one. Let's name it bootcamp and finish it. So let's create a folder over here, contracts. Uh, we are going to cover everything from beginner to little more advanced concept of Solidity. So let's start as every programming language we start with hello world. So how you can write hello world in Solidity? It's create a contracts over here, hello world dot sol, and let's start with pragma. We are going to use the 20 version. So this is how you start initialize writing your smart contracts. You have to first write SPDX license identifier. You can use an like there are different types of license, but we are using MIT here. You can use on license as well here, and this is the Spragma Solidity version. This is the version of like the compiler version or the Solidity version we are using. So you can add here uh, this also. So it basically means you are using compiler version of like 0.8.20 or like bigger, greater version than this. So let's understand how you can define your smart contract, like contract hello world, and use the curly brackets. And let's in Solidity we are going to cover variables and data types as well. I'm just like explaining here how you can write your first program as in hello world. So you can define the first the string public, it is the data type, it is the feasibility, and it is the variable, just like you do in other languages as well, other languages. So this is the feasible, this is the data types, like we are declaring string. This is the public feasibility. Why I added here public, because like we are going to see like how the getter function I am going to explain you. And this is the string, like this is the variable name, and we assign this value. So let's see, you can go to here deploy and run transaction. Here you can see the different EVM versions. So we are using the latest Osaka, and we are using Remix virtual machine here. You can connect your own wallets as well, but we are simulating transactions from here only. So you can see here our contracts get compiled, and it is not necessary the value and gas limit. So you can deploy here and open up the terminal over here. So you can see all the transaction data associated with these contracts, and you can see here the remix gets updated. So you can see it automatically great created a getter function for us. So you can see we can call it, and it is returning us the hello world. And there is another transaction over here is the from we are using this account C4 and all the data associated with this. So let's start with this. It's how you can write hello world. This is just hello world. And now let's start with variable. As in every language we have variables. So let's create another contract over here, variable dot sol, and let's start with pragma, and we are going to use the same version over here. So there are three types of variables in Solidity. One, the first one is state variable. You declare this within the contract but outside the function. That state variable directly stored on the blockchain in the EVM storage, as I previously couple of minutes ago explained what is storage. And seconds are local variables that stored in memory. You can declare it inside the functions, and we are going to see functions and all this. And there are also global variables like we use to define some matrices or like timestamp. These are the global variables. So let's declare our contract of variable over here, and let me show you how you can declare the state variable. The same, we are going to use string public, and the text, let's say hello. And since Solidity is statically typed, we don't forget to give this semicolon, otherwise it will give us error, direct error. And there is also, like, let's declare another state variable given to 56 public num, and let's say 1 2 3. So these are the state variables. And let's as I said, the second type of variables, the local variables. So for that, we are going to create a function. Let's say function do something, and let's make it public view. I will explain what public, what view, and all the, we are going to see all the data types and all these things. So here are local variables, how you can declare. So let's create a variable here. Event 256 I is equal to, let's say 123, the same value. So this is giving us warning because it is asking us to make it pure. But we are going to declare global variables also within the same function, so it will go. So this is how you can declare local variables over here that stored in memory. After some certain operations, it vanished away from the contract. So yeah, so the third type is global variable. You went to 56, let's say timestamp, and it's equal to block dot timestamp. So this is the global variable block dot timestamp, to in order to get timestamp of, like, let's say from fair to fair, on which time you got a transaction, or like for this we use this. There is also very famous another state variable, you sorry global variable, you are going to use all the time, message dot sender. This is one of the very most used global variable. So that's it. And let's there is also another type of variable. We use the constant variables and immutable variables. So let's create a contract over here. Constant dot sol 0.20 contract constant. By the way, you cannot write like you some of the reserve keywords you cannot write directly like const. So the let's declare constant variables, constant public, and let's say my address is equal to by the way, constant variables you have to initialize right over there, otherwise it will give you an error. Let's I am going to initialize the value of, and this is the industry convention of writing constant variables that you have to follow. It is not necessary, but when you write professionally code, you have to write in this convention. And there is also you once you declare I forgot to tell, once you initialize the constant variables, you cannot change their value, like within the contract again. There is also another variable type, immutable, which mm, you cannot if you wish, you cannot initialize. If you Yeah, let me create another contract. If you don't want, you cannot multiple. There is another contract, and let's declare the same variable over here. And let's make it immutable. So it is giving us error, so because we didn't initialize the value. But as I said, we this is the immutable variable. You can initialize it in constructor also, but after constructor then you cannot initialize it anywhere. So let's declare the constructor over here, and let's take any parameter using 256 my uint, and let's add let's initialize my address is equal to message dot sender, and that's it. So from here, this immutable state variable you initialize over here. I forget to add semicolon here. And yeah, why I declare this, because I'm going to declare another variable over here, public, and let's make it immutable, and let's make it my uint, and let's initialize this my uint also. So you can initialize over here also. Let me give you like this, and there we go. So these are the variables, like we learn about state variables, local variables, global variables, constant and immutable variables. Now let's go ahead and understand the like data types. So there are four types of primitive data types. Where it is go primitive dot sol, and let's declare karma quality 0.20. Let's create a contract primitive. One is the full. Let's make it public. I'm using Remix after a long time. If this reserve keyword you cannot use, and there is also another data type I'm going to explain here. Uint 256 public, and you can make it, let's say, uint 8. I'm just writing code first, and I will explain like what are these data types. Then int 8 public, Here we go. Let's format. So these are the four data types. The primitive data types. Here, bull is boolean, that every language has true or false, and this is unsigned integer. It is you can use from uint 8 to uint 256, that we previously used uint 256. So uint it ranges from 0 to 2 to power, I think, 8 minus 1, and it contains only positive numbers, and in int the same range, but you can contains positive and negative numbers as well. And this is the new data types which like other languages don't have address data type, where you can declare, or you can use address data type for declaring addresses, like in Ethereum we have 40 characters hexadecimal addresses, that this your wallet addresses or the contract addresses. So by default, if you like, I initialize this address, this um, variable here with address, but we if you declare like this, so what will be value of like by default, what value will be of this variable? So by default, the boolean value is false, and this data types value is by default is 0, and this will also 0. So what will be the contracts by default, sorry, my address by default value? So it will be like 0x, and like uh, 00000, like since like it is 40 characters address. So by default value will be this. So as we have in every languages, let's understand if else further. So let's create another contract here, if else dot sol, and let's go ahead, pragma. How if else, how you work with if else 20, same version, contract if else. And now how we can, yeah, let's declare a function over here, function, let's say fun. We are having fun, and let's take a parameter here over here, unit 256 as in x. I will explain you public pure, what is this public pure, and it is going to return us event 256. Let's open the body, and inside that function there are conditions you have to deal with, like you do in other languages, in JavaScript, C++, and like even in Python. So like same at is it is in other languages, but in, let's say, x is greater than 10. This is the condition we added over here. We can, let's type here the logic of return 0. We can add another here, else if x is greater than 20, sorry, less than 20, then return 1. And finally you can use else return let's say 2. And this is how you can use if else in Solidity. And there is also another way, if you like, you can see like in we use ternary operators in JavaScript, So how you can use in Solidity? It's the same function ternary, and let's take a same parameters and like same everything. Oof. Let's open the body, and you can directly return from. Oof, forgot to add this. You can directly return from x. If x is less than 10, then be like 1 or 2. That's it. This is how you can use ternary operators. And let's see now further the loops. So let's create another file, loops.sol, pragma solidity 0.8.20, contract loops. The Let's make it capitalize. You'll see the for loops and while loops as you know in other languages the same. So let's create a function loop here over here. Loop, let's make it public, pure, and let's understand the for loops. So this is how you declare the loop inside the function. Let's say here you int 56. Let's take a variable over here. I is equal to 0, and within the same I is less than 10, and we have to iterate. Let's say I plus plus and open the body, and inside that as we say in if else. So let's add if else here. If like I is equal to 3, then like we are not going to execute uh, any logic here. Let's add the continue. You can use continue keyword here, which is one of the like reserve keyword in Solidity smart contracts. Let's add another if over here. If I is what AI suggesting us, triple I is equal to 5, we can break from here. Let's format. So yeah, this is how loops works. If you know already in how for loops works in other languages, it's the same, but in contracts you have to deal with loops very carefully, because you can like sometimes your loops can go run infinitely and you end up losing all your Ethereum as a gas fee, because like every code you write here over here, you have to pay some price which we call gas. Unati covered in previous workshop. And let's go here in the same function. We Let's see while loop. Let's see while loop. Let's take an local variable here. Don't initialize it any value, and file. Let's say j is less than 10. It should iterate infinitely like this, not infinitely, until less than 10 it should continue. So that's our sixth lesson of loops. And one of the like beauty of Solidity, I personally love mapping. So let's see mapping. How this is the not a new, but in other languages like Python or Rust, you can think mapping as an dictionary. uh, let's say like why mapping exists. Let's say you have to access data from by like any employee, or like by inputting employee number, you have to take his address or like his salary, anything. So for that, problems like this, for that mapping exist, you can think it as a dictionary. So let me make it down over here. Pragma Solidity 0.8.20. Oh, it's 9. It's not contract mapping. You cannot use this word directly mapping because it is reserved. It is going to give us warning. So that's why I'm making it capitalize. So how you can declare mapping? So you have to use mapping keyword and followed by this, open the these brackets, and from, let's say we are mapping addresses to uint 256. Let's make it public. This is the visibility, and the variable name like my map. And let me tell you, mapping always returns the value. So let's see in action function. Let's say get, and let's take off here parameter of address addr, make it public, and view, it should return. Yeah, AI is suggesting us like completely right. And from here you can return mapping of my map using this brackets, and pass the address here, which means you are accessing this address data. Like, you can think it is an like dictionary. Let make it format. Yeah. And there is also very complex nested, like we can manipulate mapping. We don't have much time over here because like due to timing, I'm not going to uh, explain you how you can set mappings and remove. I'm going to cover only on like basic how you can declare. And yeah, so let's go ahead and let's understand how nested mapping works. Nested mapping. Let's create another mapping over here. Mapping address of the, we have to map nested map. You can see in name itself, we have to map another mapping in, like we have to nest. So let's declare mapping inside the mapping, and move into 56. Let's make it build public nested, and let's create a getter function here. How we can get nested mapping address of the UTR. Also taken another parameter, since we are mapping inside the mapping, it is the nested mapping. So let's take here another event to 56. Let's say let's make it public view, and it should return bool because we declared here bool. Yeah, AI is suggesting right. And from here we can return nested this mapping variable, and here it's at the address and I. And that's it. How you can use with deal with mapping. And let's go ahead and understand the array that we this data type. It's very common, like it is not common, very important, and there is always in every programming languages. Array.sol. Let's understand array. I know many of you know already know array. Let's go and understand how array works in Solidity. There are two types of arrays in Solidity: fixed size arrays and dynamic arrays. So how you can declare it? So let's first declare the contract of uh, array, and let's declare here uh, event 256. Open this brackets and let's make it public, and let's not initialize the value. Let's make it another variable over here. Event 256 public array 2, and let's initialize its value 1, 2, 3. So this is how you can declare array in Solidity. Let's create a function over here to how you can get the value of the array. Function get, and let's take an parameter over here, event 56. Let's say I. Let's make it public view returns. There is a difference between this returns and the return. So we are going to return event 56, right? And return, let's say array, and over here this I be taken as a parameter. As all the error are gone, format. You can get, like, you can manipulate with arrays. Like there are array itself also again a huge topic. You can play with array by going through Solidity documentation. You can get array length, and you can push and like pop. You can delete some uh, you can push some data, you can delete from array data, and so on. So let's go ahead and understand the enums. Let's create another file over here, pragma 0.8.20. Let's create a contract of enums over here. So sometimes we have to deal with multiple situations. Like let's say we are writing smart contracts for like e-commerce. Let's say for in India we have Flipkart or like Amazon. There you have to deal with some status, like if the status is pending, or like if the ship or the user accepted or the user rejected. So you have to deal with multiple situations. For that we have enums in Solidity. So how you can declare enums? Let's say we are using here like status. So how this is how you can declare enums in outside the functions and inside the contract, within the contract. And let's add, as I said, we have to declare we have to deal with multiple situations. For that, let's add ship, and let's say rejected or cancel consistency rejected or the cancelled, and so on. So and for oh, this one of the code. Let's go. And you can create that's enums custom data type, just like we use string and event. So you can create a custom your user defined like custom data types of this enum. Let's say public, and you can declare like this. So you can nest them together and you can use in your function. And let's say how you can use this in function get by creating, let's make it public view, and returns the entire this data type we declared over here. Let's copy from here, and you can declare, sorry, you can return this from return this status. Let's not forget. So this is how you can deal with enums. Let's go ahead and understand struct. We have struct in Rust as well. If you return Rust or any like kind of low level programming language, struct.sol, and let's go ahead. Solidity 0.20, and you have to declare struct just like enums outside the functions and inside within the contract, and you can also import struct from others files as well. So let's understand how you can declare struct contract structs. Let's say struct, you have to use this keyword struct. Let's say to do and not to do, and inside that you can use your different data types and wrap them together just like enums, but don't confuse with enums. It's struct has different use cases, and enums has different. So let's add here one of the string variable, and let's make it let's name it text, or you can add another, and let's make it completed, or like anything you can wrap, like you can declare as many variables or the data types as you want. And like enums you can also create the like array of struct, or you can define like data type as well. So let's create an array like to do public to do's, and just like array we can play with struct in different manners, different ways. So you can initialize struct in three ways, like in calling like a function within the function. So it will be very long workshop. So, and also key value mapping, you can also initialize the struct value, and you can also initialize the empty struct, and then you, if you want, you can update in within the contract. So that's the struct. Then let's, I've been writing functions, and you, I didn't even explain the what are like functions about the functions. So let's understand the functions in Solidity. Pragma 0.8.20. Let's declare the contract func function, and functions like we've been returning the only single value since so far. So let me tell you, you can return multiple values from function. Like you can declare the function like this function, and let's say return many, and from here Let's make it public. We are going to see visibility as well, so just bear with me. What are the pure, what are the public, what are the use, and so on. Returns, and from here you can return multiple values. Let's say from int bull, or the let's another event. And how you can return from here is you can return and open its brackets. And since we are using uint, let's say 1 false, and as well let's say 10. This is how you can retain multiple values. And return, you can give name it as well, like return value can be named. And you can restructure some values within the functions as well. So that's how you can declare the function we've been writing. But let me explain, like this is the function keyword you have to use. Then return, like we use return, you have to give the name of the function, then this bracket just like we use in JavaScript or the other languages. Then the visibility, and like what types, pure or view. Then if you are returning anything, then you have to use this returns keyword, not an return. If you use return, then it is going to throw an error. So always check this over here. We are going, you have to use returns, not an return. Then after functions, we have to see like what is this view pure we've been using. So let's create another file here, view and pure dot sol from solidity 0.20 contract view pure. So here we go. Let's take a variable here, state variable here, and let's make it public. And oh, sorry. And let's say x is equal to 1. So I'm going to write two functions, and in two functions you will get what is the view and pure. So function, let's say add to x, and uint 256 y. Let's make it view. So what is view? Public. View promises us, we developers, that I'm not going to modify the blockchain state, this storage. So the view, the functions we make view, it is not going to change anything like what we declared over here. So that uh, view promises us. Let's say let's returns. Let's see in this action event 256, and we are going to return x plus y. So it is not changing anything in, like we initialize it is as an 1. It is not going to change anything in this state variable in blockchain storage. So it is only read from over there. And pure function is completely pure, which he doesn't deal with any like state variable or the blockchain storage. He don't read or don't modify any blockchain state. Like if you want, I can even give example of this function. Let's say add, and let's take a variable of event 256. Let's say I, and event 256, let's say j. Let's make it pure, public pure, and it is also going to return same. And now, since we are not reading or the writing, we can directly play with this memory. We can directly this variable or this memory I plus j, and that's it, view and pure. Then there are also many topics in Solidity like modifiers, events, feasibility, and so on. So you can learn this on by going through documentation as well. But like I'm going to cover here very important topics you need to deploy your smart contracts. So in the last file, we are going to see uh, the feasibility or feasibility dot solve. Then we will write. We will see the reentrance is a very basic or very basic also, and also very famous attack, reentrance attack. And then we will deploy the smart contracts using Foundry, and we are going to wrap up pragma solidity 0.8.20 contract feasibility. So there are the feasibility we've been using public, and that's you, most of you get curious like maybe got curious like what is this public he's writing. So there are four types of feasibility in Solidity smart contracts. You can declare function as an private, you can declare function as an internal and external and public. We most of the times we write public, but let's see what are the, like I introduce you internal and what is the private, what is the external. So let's write, like let's make it base contract first so I can make you understand better. And let's write a private function over here first. Function private func, and as we made it public previously, let's make it private. You can make it private function like this, private pure. Since we are not dealing with any blockchains, that you have to make it pure. And let's return, yeah, AI is suggesting a string, then let's go for string. By the way, whenever you are using string is special data types, so you have to use memory keyword with solid. It stores in memory. If you know like what is the heap memory storage or stack, like if you didn't kind of for DSA, you definitely have an idea like what is memory and all of this. So from here, let's return private function called. So private functions you can use in the same contract only. Like you can, I declared here multiple contracts, but contract, let's say base 2. So the functions you use, the private functions you can use in the same contract only. How? Let's create another function over here. Let's name it test private, and let's make it public. Now this is what we've been using, public pure, and it is going to return us string memory. Same, since we are going to call this function, and let's call this function here. So that's when name returns and explicit to it is just, yeah, it is going to be forget to add return keyword here. So This is the feasibility of private functions. You can declare for your own purposes, like any kind of logic you have to use custom in within the same contract. So you can use the private visibility. And you can use, when you declare function private, you can use only in the same contracts, you cannot use this in another contract. So there is also uh, public functions you can use in, like you can, public function can be called anywhere in the same or the another contract or your another file as well. Like you can import contracts from there to here. This is inheritance, very advanced concept. So you can use uh, where is our visibility, yeah, uh, the public functions, then external and internal contracts. So internal functions, if you declare the function anything instead of public to internal, you can use, now it is going to give us one, let's make it public only because it is going to throw an error. If you make a function internal, you can use the within the internal function within the file. I'm not saying within the contract or the another file, within the file. This is our visibility file. And you can declare any internal function here, and you can this use this in another uh, contract in within the file. Then there is external types of functions you can use. uh, the external type of functions can be called by another contract or another, like Unnati explained what are the EOs, another external, like kind of wallet addresses as well. And there are also state variable we declared. You can use you can declare state variables also as in private or internal. And by default, like we are using we've been using public, but you can make it private and internal as well. So let's see how string private, and let's say private variable, and let's make it private only variable. That's it. Then string, let's make it internal, same visibility as I explained. Same, you can use only within the file. You cannot you access this private variable outside this contracts. You can access this only the same contract. And the public, we've been declaring or the last couple of minutes. Yeah, let's make it public variable, and let's initialize it at a public variable, public mail. So that's the important, some of the important topics. There are also many important topics in Solidity, like events and errors, but it will be long. But let's see some, like when error. This is one of the important topics, errors dot sol, and pragma make it 0.820 contract error. How you can deal with error in Solidity, or how you can manipulate. So in Solidity you can use require, revert, and assert, and you can declare your this errors comes into like control flow, or like this. So in Solidity we have require, we have revert, we have assert. It has different use cases. Most of the time you are going to use require, and when you are doing professional development, and uh, like you are going to rigorously test, there are multiple types of test in Solidity, like invariant unit testing and fuzzing and so on. So when you are dealing with testing, you are going to use assert. So let's see one by one and how you can declare custom error. We use custom error to save, like for gas optimization purposes, or this is one of the best way to optimize your smart contract, so user can pay less gas. So let's see require by function test require. This will be our last lesson. Oof, I forgot to add this one. Let's take it even to 256 of I. Let's make it public, and there is no state variable, so make it pure and add. So we can use require, which is the reserved keyword in Solidity. If I is greater than 10, then there is another, like we have to add a condition here in string. Input must be greater than 10. Then function test revert the same. Let's make it pure, and let's use you have to use revert inside the if else statement. Sorry, if a yeah, if else statement. Let's use I is less than or is equal to 10. Then you have to use this revert keyword over here, but it is very costly. It cost very like huge gas, so we are not, but just for your information purpose, uh, I stress you here, revert like input must be greater than like 10. And there is also another assert. Most of the time we, like, you are going to need only this require in contract, but when you are doing testing of smart contracts, I will also show how you can test your smart contracts in Solidity, sorry, in Foundry. Function test assert AI is suggesting us right, and let's go ahead, and this is how you can use assert with a condition. But before that, we have to declare a variable here, or here it's the state variable. We can declare where also. Let's say public, and let's name it num over here. And here, if you have to add a condition, it should be like 0. Yeah, not a pure. You have to make it view, because we declare the state variables here, and we copied pasted. Yeah, so that's how you can use assert. So revert and assert, we are not going to use. And how you can declare the custom errors here. So you can declare error, like if you are dealing with like kind of DeFi protocol, or DeFi protocol contracts to save gas fees, you can declare your custom errors over here on top of contracts. Insufficient, let's say my face spelling mistakes, insufficient balance. And you can pass parameters as well over here. Int 256, not 56, 256 balance let's short it bal and even to 256. Withdraw amount, I think it's going to. And now you can use this custom errors inside here also. Like you can move, revert, and you can take parameters over here, and you can pass this parameters here. So it is giving throwing us error because it is expecting to arguments or the parameters because we are not passing. So let's comments down it. So that's it. We've been we learn about a lot of topics. So that's not enough, but almost we covered a lot of important topics of solidity. Now we are going to see very famous and like mostly happened. We lost like millions of dollars due to this attack. We are going to create. I will create a very uh, kind of vulnerable contract, and then uh, one of the best security practices of in solidity contracts, CEI, you have to use check. CEI stands for check effect interaction. So I will create a very basic vulnerable contracts, and how you can. I will also create like how you can implement CEI over here and prevent re-entrancy attack. Um, that's it. Let's create a new file here. Re with re-entrancy dot sol and Pragma 0.20. Let's create a contract of vulnerable. What contracts we can take? We can take in like bank contracts, let's say, not an alt. So let's make it vulnerable. What is the spelling mistake? Bank. And let's declare mapping over here of address to event to store public balances of in, in our bank public balances balance on not and let's create a function for depositing some like kind of ETH function deposit and here we have to make it external. I explained what is external, and we have to make it table and balances of this mapping we are going to use of message dot sender, the global variable. Let's make it plus or equal to message dot value. And now this is the deposit function. It's clear it is not vulnerable because just one line, not just because one line, but it is not vulnerable because I am saying. And now let's declare the vulnerable function in our contract. Function for withdraw and let's make it external And let's take an variable over here in 56 of amount and balances. This one here, balances of message dot sender, right? Yes. And now let's go ahead. As I said, check effect interaction. So let's check first, but let's not check require, add and require amount should be, let's add a condition here greater than 0, otherwise it will throw us no balance, right? Maybe this, yeah, we forgot to add comma over here. Now let's take in another variable here, bool, let's say success, and from here let's say we have to make it table. From here message dot sender, and we are going to use, I think we should use, yeah, call. It is the low level function in Solidity. You can directly deal with, and we have to pass value with amount over here. Mm, and empty string, and let's add require here, and the condition should be success. It should be success, otherwise it is going to fail. Let's say transfer failed. So here, what is our order? Check effect interactions. So here what we are doing, you will get this, it will not make sense to you now, but it will, we are interacting here first, we are interacting here first, that's why it is vulnerable kind of. We, our pattern is CEI, we have to first check, then effect, and then interaction. Now here in what we are doing, we are interacting first, and then we are going to update, or the like, there is our mapping balances, copy of message dot sender is equal to 0. So here we are effect, let's make effect. So our pattern is check effect interaction, but we are interacting first and effecting its latter. So how to secure this smart account? This is the vulnerable bank, like vulnerable function. How you can actually implement check effect interaction. So let's create secure bank, or like secure contract. Let's secure this contract. So this is the very basic security practice contract. Let's make it secure bank or what, and same mapping. Let's copy from here and paste, and same function, but we need to add function deposit, and inside the deposit function, this we can make it secure by here require, and condition, add condition message dot value should be like greater than 0, or it will throw an error like deposit must be greater than 0, like blah blah blah. And how you can actually implement CI pattern. So the same function we are going to use. You can, let's copy and make it function external. And now just keep an attention here. Let's add checks first. Event 256 amount, and it should be like balances message dot sender. And here add require statement as we did. Amount should be greater than 0, or add a condition, throw an error, no balance, or like no balance available. Now it is giving us warning. Now the second effect, what we did here, we directly we were interacting, that's why it was vulnerable. So effect, we have to use balances message dot sender is equal to 0, and now we are going to interact. Now we are going to interact of with this interact, like spelling mistake. Now let's see its bull of success, and there is equal to table, and the same message dot sender. Let's copy from here, and now here require success, otherwise it is going to throw an error. Like let's say in our decentralized bank we have ETH, like transfer failed, failed, and that's reentrancy. So we've been using Remix. Now it's time to create like our first ERC20 smart contracts. For that, we are going to use Foundry. We have another tool also, Hardhat, like Hardhat, Hardhat 3D accommodation. But we are going to use Foundry. Foundry is blazing fast smart contract development tool, which comes with four powerful components: Forge, Anvil, Cast, and Chisel. If you know JavaScript, it will be very easy for you to get started with Hardhat. This is also widely used tool in industry, and you can write as well and test smart contracts there and deploy in professional development environment. And you can use Foundry if you want very fast. Foundry is built in Rust, and if you know Rust is super fast. So as well Foundry, we are going to use Foundry. So let's create our ERC20 smart contract. Like we are going to use very simple, um, like using OpenJavelin, we are going to write ERC20 smart contracts. Let's start with Foundry and let's create a new folder over here. Oh, it is simple. Let's create ERC20. Let's open it in your VS Code. We are going to use VS Code over here. Open up terminal, and how to install Foundry. You can go and run this command. If you are on Windows, you must have installed. You can use WSL. Also, you must have installed, I think, C++ compiler, and then Rust, and then you can use this command and paste directly here. So I already installed Foundry in my computer. I'm just going to run this Foundry up. Just and you can see Foundry on my computer. So you can see we have a stable version installed. There is also nightly version. So you can now we have available forge, cast, and wheel chisel. These are, let's make it clear. Now let's initialize our project by running this command forge init, and we are going to use OpenZeppelin, just like in any JavaScript project. We use npm like other packages like npm install React or Next.js like this. We use in Foundry like forge install. I think it's the same Open Zeppelin. If you know Open Zeppelin, Open Zeppelin is open router. Open, open Zeppelin. So you can use Open Zeppelin is like you can think it is like just like we use React libraries and the components. Open Zeppelin is like the same for smart contract. It gives you the pre-built contracts that are audited and secure. So you can use there for that for building ERC20. We are going to use Open Zeppelin. I think yeah, it's the same command. Open Zeppelin contracts. I forgot. Uh, Open Zeppelin slash Open Zeppelin slash contracts. Is it the same? Yeah, there we go. It is installing. Since it is installing, we are going to delete these files because these are the pre-built contracts which comes with when you initialize the Foundry project to test. And it is taking time to install. Maybe my internet speed problem or what. It is very slow. It's taking time, guys, to install. Stop sharing. When are you there?
Yes, Pandit.
Actually, I think the network problem because it is taking a lot of time to install the Open Zeppelin library. So
Okay, no worries.
can we wrap this up or we can continue? Like what is it?
Yeah,
I think
according to me,
there's
like what we can do, like we can share the resources where people can learn more about OpenZeppelin and Foundry and how they can deploy and things like that. So that would be more helpful. Otherwise, the session would be way too long, like around 2 hours and so on. Then people will lose interest in the middle of it.
yes because this is going to be very long because like we have to explain how to write and test and write and script, and it will be long contract maybe. We can share the resources how you can deploy your
Exactly. Like,
contracts, or yes.
yeah, like if you have the code base and so on, so you can post it on like GitHub, and I can share the code base and
Yeah,
resources and bit about it over here
yeah,
in the YouTube comments.
yeah, yeah. Yeah, yeah, I will like whatever we learn. We I'm going to create an open source repo and we can share with them. And also there are some resources on my YouTube channels where I declared ERC20 and like other smart contracts. I will share this resources as well.
Oh, perfect. Sounds good. So, this is basically what we will do. So, thank you everyone for joining us out. So, what I will do, like, I will share all the resources. Pandit Twitter ID, like, he's very active over there. So, if you come up with any doubts during the session or after the session, so you can directly reach out to him and ask your doubt either in between the build-a-thon and so on. So a smart contract specific doubt you can ask with Pandit. And thank you for joining us and being over here till the end. And wishing you best of luck for the build it on, and see you in the next session day after tomorrow. Have a good day ahead, guys. Bye bye.
Bye bye.